All right, you guys, I am back. I promise this one's going to be a much shorter recording, mostly because I already started example 3, as you guys should hopefully be almost done with it, or as far as you could possibly get with it. I went ahead and started it. I have not finished it yet. I went ahead and set my red line equal to y. I had y is less than in negative 1/4 x plus 1, so it's in slope-intercept form. I went ahead and tested the point 0, comma 0, which was true. So as you can see from my little arrows here, I'm going to shade everything towards 0, 0, aka everything below that red line. Now notice that red line is dashed. Okay, so then I went over to my blue line, the second equation there, and I went ahead and also put this in slope-intercept form. Now, something crazy happened here. I went ahead and divided by a negative 8. This was the tricky part. Remember, anytime that you divide or multiply by a negative number, you're going to flip that inequality symbol. Okay, so please make sure that you did that. After I flipped that inequality symbol, I went ahead and again tested the point 0, comma 0. I ended up with the result of 0 being greater than 1. That is not true. So I'm not going to shade towards 0, 0, which means I'm going to shade everything above. So as of right now, if I were to be shading, I would be shading in this wedge right here because that's everything below the red line but above the blue line. But I'm not done. I still have that green line. So here we go. I'm going to start at my y-intercept of 8. And I'm going to go up 3 into the, oh no, I'm off the graph paper. So instead of going up 3 into the right 2, let's go ahead and go down 3 into the left 2 and down 3 into the left 2. Notice on all of these lines, I am putting in quite a few ordered pairs to make sure that everything is very, very, very accurate. AKA, when I go ahead and if I needed to find my points of intersections of these lines, I'd be able to do that. Okay, and so I have that graph right there. All right, I'm going to go ahead and test a point. You guys have already discovered that my favorite to test is always 0, comma 0. So I'm going to plug in a 0. It has to be less than or equal to 3/2 times 0 plus 8. 0 is less than or equal to 8. That is true. So I'm going to shade my green line towards 0, 0. Now, if you're choosing to shade each line separately instead of doing what I'm doing with little arrows, that is totally fine. But at the very end of your problem, you have to make it very clear to me what your actual final solution set is. Also, another thing to notice, whoa, Miss Chapman, you made a mistake. That should have been a dashed line. I was going to say the last thing to notice is make sure that your boundary lines are correct. My apologies there. So let me go ahead and toss in a dashed line here. Oh, so much better. All right. So my red line is a dashed line, my blue line is a dashed line, and my green one is the only solid line. So the last thing I need to do is find my intersection, and it's below the red, to the right of the green, and above the blue. AKA it's in this little portion right here. Okay, so again, if you're shading for each line separately, that's totally fine, but you need to make sure that I'm able to see which is your final solution set. Every ordered pair that is in this black region will go ahead and satisfy all 3 of these equations. Anything that's not in that black region will not satisfy all 3 equations. All right, last but not least here, for problem number 4, I'm going to go ahead and just reiterate what I said in the first problem. To write the equation or inequality of any line, you essentially need 2 things. You need a point or y-intercept and a slope. So the first thing I'm going to do is I'm going to go ahead and work with my solid line first, mostly, as I can tell right there, is going to be my y-intercept. So for the solid line, my y-intercept is at 0, 6. Okay, so there's my point. I also am going to need to find a slope. In order to find a slope, I really should go ahead and find another nice point on my line. I have a few of them. Maybe this point or this point or this point, your choice. And then you can just calculate your rise over run. So I'm rising up 2 and running to the left 1. So my slope for this one is going to be 2 over -1 or -2. If I were to write this as an equation, it would be y equals mx plus b. I know my slope is a -2. I know my y-intercept is 6, but it's not an equation. There's shading involved. So I need to go ahead and write this as an inequality. Now, my personal preference for doing this, and again, there's a lot of different ways you can test points, but my personal preference for doing this is to take a look at that y-intercept. I know that if I'm shading above the y-intercept, it's going to be a greater than. And then I look at the boundary line. My boundary line is solid, or it's going to be an or equals to. Okay, let's try another one here. So I'm going to go ahead and go with my second equation. Again, I need 2 points. I need a point, or sorry, 2 things. I need a point and I need a slope. The point that is ideal is that y-intercept if it's available to you. Okay, so my y-intercept for this one is going to be at 0, -3, and I need a slope. So let's see if I can go ahead and find another nice point. Here seems to be one. Here seems to be one. I've got another one, I think right over here. So I'm going to count. I'm up 1 over 1, 2, 3, 4. So my slope is going to be a rise of 1. Okay, rise of 1 and a run of 4. Again, slope-intercept form, y equals mx plus b. I know that my m is a 1/4. My y-intercept is -3. And now I need to determine where my shading is. So keep in mind, my shading is everything above this blue line. So if I look at my y-intercept and I know it's above, I know this is going to be a greater than symbol. It's a dashed line, so I am going to leave it greater than. My final 2 solutions here would be y is greater than or equal to a -2x plus 6, and y is greater than 1/4 x minus 3. You'll have a chance to practice this again in tonight's homework. All right, so last but not least, you guys can pause my video, try example 5, and when you guys are done with example 5, then you can go ahead and press play again and all the solutions will be there. So again, go ahead and pause. All right, hopefully you guys have had enough time to work on the problems. And I just want to go ahead and show you guys my solutions. Some of you guys might be unfamiliar with this terminology that is here. All of this is saying that I would like to know what all of the ordered pairs are, such that the y values are between -3 and 5. So I know if I go ahead and cover this up, to look at one at a time, y is less than or equal to 5 is a horizontal line. I have a y-intercept 5, it's solid. My second one, I have y is greater than a -3, so we're going to go to -3, a horizontal line, it's dashed. And I want everything that is all of the ordered pairs that are in between those 2 lines. So there should be your solution set for the first one. The second one, we've been talking circles. So this one was actually interesting. I had a center at 2, -4. My radius went 3 in each direction. And so I ended up with this beautiful solid boundaried circle. Okay. And then I had to decide which way I wanted to shade. And that was where it became really interesting. I went ahead and chose the order pair 0, 0 to plug in. And here's all my work for plugging in. I got a -2 squared plus 4 squared, so I had 4 plus 6, 20. 20 is less than or equal to 9. That's not true. 20 is not less than 9. So I knew that I didn't want to shade towards 0, 0, aka I knew I didn't want to shade anything on the outside of my circle. So the only option left was shading inside my circle. All right, and then we have this final one, this one that I did in purple here. And again, if I were to read this out loud, I want all of the ordered pairs such that it satisfies this inequality. I would like to know where all of my x values, okay, and if I take the absolute value of those x values, are less than 4. So again, I'm only looking at the x values. So for example, if I put in 2, 2 is less than 4. 3 is less than 4. But then some of you guys are like, well, Ms. Chairman, why did you go over into this negative zone here? Look at that -3. Is the absolute value of -3 less than 4? Well, the absolute value of -3, it's 3 away from 0 on the number line. 3 is less than 4. That is true. Okay, so it's going to be everything that is in between and not including, hence the dashed lines, for in negative form. Okay. All right. As a friendly reminder, you do have a quiz tomorrow. Your quiz is going to go ahead and cover such concepts of, can you write the equation of a vertical line, a horizontal line? Given a slope and y-intercept, can you go ahead and write the equation of line? Given 2 points, can you write the equations of the lines? Can you write the equations of medians, altitudes, perpendicular bisectors? Can you go ahead and do questions like the warm-up today? Okay. As of right now, it is 13 questions long and 33 points. But I will let your sub know if that ends up changing. All right. Other than that, I wish you guys good luck studying. Remember, none of the material from today's notes are on tomorrow's quiz. It's just covering section 13.1 to 13.3. If you have any questions, you guys are welcome to send me an email. I'll check my email. Other than that, best of luck tomorrow. Board problems first thing. And as soon as you guys are done with your board problems, then you can get started with your quiz right away. All right.